Good morning, math people. Welcome to the lesson. I'm sorry I'm not there with you today. Today we're going to take a look at how to find the length of a side in a right triangle when c squared equals a squared plus b squared doesn't work. So if we can't use Pythagoras, if we don't know the lengths of all the sides, but we have some angle information, how can we use that to find the lengths of sides? So to get you started, one, we're on page 10 of the notes. Two, if you ever have questions, of course, jot them down, email me, come see me, whatever. I'm sorry I'm not with you today, but I'll be back shortly. You can certainly email me. Be happy to go through questions. To get you started, you don't really need to know the names of all these different types of triangles. However, I would like you to find the right triangle. Remember what a right triangle is all about. Label the hypotenuse. Okay, and then what I would need you to know, or maybe what we can remember, is that there are other sides of a triangle. And of course, one of them is called the opposite side, and one of them is called the adjacent side, or at least when we start to put in a little label called theta. It doesn't really matter that you know that this is called theta. We often use it for something called the reference angle, which is just sort of math speak for we care about angle theta. Okay, so that's all that we're really looking for, and all I'm really asking you to do is label the hypotenuse, label the opposite, label the adjacent. Okay, so please pause it, find the right triangle, throw on some labels, and then play it. Okay, I'm hoping you've got some labels. I don't really know. I hope you pause it, hope you try it. So one, of course, here's the right triangle. What we want to look for is that 90-degree angle kind of symbol, right? We want to remember that that little square tells us it's 90, and opposite to that, opposite to the right angle, is the hypotenuse, which is the longest side of any triangle. Next up, the reference angle, and so that's going to make this side the opposite. Maybe you remember that, maybe you don't, not to worry. And then so we've got one other side of a triangle, and that's the side that's next to theta, and that side we call the adjacent side. And adjacent is just a word for next to. So what we're after today is how to solve triangles for side lengths, but we're going to use something called SOH CAH TOA. SOH CAH TOA is also known as the primary trig identities. And again, what we need to do, as you've done there, we'll review it again, label a triangle's hypotenuse, adjacent side and opposite side. We need to remember, or we need to understand, sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and the TOA, tangent, is the opposite over the adjacent. We're going to set them up so we can find some side lengths, and then we need to know how to find that. So we're going to have to use some tech. We're going to have to know how to use our technology and figure out how to solve these problems. How to find the length of a side in a triangle when we have some side lengths and some angles. So just some review. Sorry, not some review, but some key information here. We're going to look at SOH CAH TOA. So SOH CAH TOA represents that the sine of theta is the opposite over the hypotenuse. That's where the SO part comes from. You might find it more helpful to write it this way, and then you'll see the opposite over the hypotenuse. That's to say sine of theta is the opposite over the hypotenuse. Next up, we have the CAH part, and that is to represent cosine of theta is the adjacent over the hypotenuse. And again, you might want to write that as CAH C, or cosine, equals adjacent over hypotenuse. And then finally here, we've got the tangent of theta, which is the opposite over the adjacent. And again, let's do that over here. Boop. If you write this as TOA, it sometimes helps you put them, put the ratios together, put the fractions together, put the formulas together. Okay, so what are these opposites? What are these adjacents? Well, one of the things we need to remember is we've got, we'll be dealing with 90-degree triangles. So exclusively 90-degree triangles, right triangles, because they have a hypotenuse. And you'll notice in the identities we're dealing with hypotenuses. Hypotenuse? Hypoteni? Who knows? So the 90-degree angle, and then opposite the 90-degree angle, you get the hypotenuse, which is the longest side in any triangle. So that leaves a couple other sides. Two other sides, in fact. We call those opposite and adjacent. Where opposite and adjacent come from are in reference to theta. Okay, so we always need to find this theta, this reference angle. Maybe we use theta, maybe we don't. Maybe we just care about that angle because that's the way the problem is set up. We've got two paths that are diverging in the woods, and we need to know which one is less traveled. All that kind of fun stuff. Okay, so let's label a couple sides. If you want to pause it, throw down some labels, that'd be great. You can test yourself. If not, we'll do that later. But for now, here is the right triangle. So that makes this side opposite to that, the hypotenuse. Next up, we have theta. Okay, and as far away from theta as you can get is the opposite side. We would say that this side from here, this side here, is opposite to theta. And that's what they call it. It's as far away from theta as you can get. So again, the hypotenuse is the side away from the right angle. Somewhere you'll have a reference angle, somewhere you'll have an angle you care about. Maybe use the little theta, the little symbol in there, but you got an angle you care about. The farthest away from that angle is your opposite side, and that leaves over just one side left over. That last side left over is called the adjacent side. And adjacent means next to. It'll be the side that touches the theta, the reference angle. Opposite means farthest side from the theta, or the angle that you care about. Okay, opposite just means away from. So in any case, those are the names of the sides of the right triangle. Absolutely critical. You've seen hypotenuse before when you looked at Pythagorean theorem, which is c squared equals a squared plus b squared. So now we want to use those to solve for some angles. And to do that, I need you to pull out your calculator. And shocker, I'm sure you're going to hear me say, not your phone, gotta use a calculator. So see if you've got one today. If not, of course, make sure you bring one. You got to figure out how it works. They're not all the same, unfortunately. And the time to figure it out is not on the test or the exam, of course. Okay, so this is a great opportunity. You can run through your calculator right now and figure out if your calculator is working the way that that it should based on the work that you see here. So let me run you through that. Just down below, we have an example. We're going to solve for some side lengths. Tip number one, your calculator needs to be in degree mode. So you might look through your calculator. On the top of your calculator, you might see a D in a little square. Maybe you just see a capital D. Maybe you see a deg. But you do not want to see rad. If you see rad, that's not good. If you see R, that's not good. If you see other stuff like grad and whatnot, also not good. So again, you're looking for D, you're looking for degrees. Okay, so that's what you got to find. And you maybe have to press the DRG button on your calculator a couple times so it goes until degrees. We might have to go through the mode and the setting. But in one way or another, we need to make sure that you're in degree. Okay, I don't know if I'm in degrees. Help me out. Am I in degrees or not? Okay, so what you want to do is we want to run through this problem a little bit. And while I'm at it, I might as well just set up the triangle so we can understand what's going on here and just use this as an example. So again, we got a right triangle here. So that tells us we can use SOH CAH TOA. Opposite to that right triangle, we have the 6 kilometer long side. That's the hypotenuse. Next up, in this top left corner here, we have this 40 degrees. And I should put a little degree symbol in there. I just wonder if it's missing from the triangle. In any case, that's going to make side B here the opposite. And then we've only got one other side left, the adjacent side, that's side C. So we've got a bunch of labels down. Now, what we have on the right here is just the opportunity to solve for side B. Side B is down here at the bottom. We want to figure out how long is side B here. So we're going to pick the sine ratio to solve for side B because we know the hypotenuse, right? That's here. And we know this angle. And the only thing that we're left with is this opposite. And we can find that because that's our last unknown in the formula. But if not, we would plug it in, see if we got all the stuff. If not, we back it up, we try something else. So here we go. We've got the formula. Sine theta is the opposite over hypotenuse. Next up, we're going to sub in 40 degrees for the angle. So again, the angle theta, that's our 40 degrees. We can sub that in. The next piece is the hypotenuse. We know the hypotenuse is 6 kilometers long. So where we find that, we can plug that in. Next up, we want to isolate B. We need to get B all by itself. So to do that, we're just going to have to multiply by the 6 on the other side because we're dividing by 6 on the right-hand side. So that leaves us with this expression. 6 equals sine, or 6 times the sine of 40 equals B. Okay, suppose that's an equation. So here we go. I want to figure that out. So one, I want to figure out if my calculator is going to work. And the other way to look at that is it's going to look like 6 times the sine of 40. So I'm in degree mode. I press sine 40, and my calculator tells me 0.642787 something, yada, 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 and on it goes. Okay, so you want to do that with your calculator. You want to put in sine 40 and see if you get that number. If not, you might need to do 40 and then sine and get that number. At which point you want to do times 6, because that's the rest of the equation, and it turns into B equals 3.856. And those will be in kilometers, but for now we're just checking to make sure that your technology works the way that you want it to, and you can plug these into your calculator. And again, the calculator is going to be different. They're not all the same, so we want to make sure we figure this out. Likewise, on the right, you can take a look at the situation for the cosine of theta, solving for the adjacent and the hypotenuse. All that's really different in this case is one, we're going to use the cosine relationship. Cosine is the adjacent over hypotenuse. And then why we're doing that really is because we want to find side C. Okay, we want to find side C. So side C is the adjacent side. We figured that out over here when we labeled the triangle. So we can sub in the angle of 40 degrees. We can sub in the hypotenuse of 6 kilometers. That gives us that equation there. 6 times the cosine of 40 equals C. And again, we want to plug this into our calculator. So for that to make some sense, of that, it looks like 6 times the cosine of 40. So the cosine of 40 is a couple of kids that are giggling and probably getting in a little bit of trouble, I bet. Anyways, that's my youngest, Violet. She's hiding from her sister. In any case, cosine of 40 is 0.760444, and it goes on and on. Okay, and then we're going to take that value and multiply it. So, cosine 40 times 6, and that gives us 4.59, and so on and so forth, 62, blah, blah. And those will be kilometers for the length of side C, or the adjacent side. Okay, so we need to make sure your tech's working. If tech's working, let's try some problems. So here's a little bit of practice. I'm going to leave the examples up there, and we will see if we can solve this practice here. We have triangle PQR. So first step, read the problem. In triangle PQR, angle P is 90 degrees, side Q is 12 meters, and angle QRP is 35 degrees. Okay, what does any of that mean? Who knows? But it says we have triangle PQR. So let's throw down triangle PQR. The other thing it tells me is I've got a 90 degree angle in there. So let's throw in a 90 degree angle in there somewhere. Oh, it also says that that is called angle P. Angle P is 90 degrees, so let's throw the P in. All right, and then side Q is 12 and QRP is 35. Well, let's throw in a Q and an R. Well, we got the P because that's already there. So side Q is 12 meters. That's little q. Okay, so little q. So we go across from the big Q. Opposite big Q is little q, and that's to say side Q is 12 meters. This is going to get muddled, so let's take that back out there. All right, we got next, angle QRP, angle QRP. Really, we're just looking at the R in the middle because QRP is here. Okay, so QRP is 35 degrees. Okay, now, I need a question. Let's say find opposite side length. Okay, so we've got this angle of 35 degrees. We've got a right angle. We've got side Q. We need to label a few sides. Generally, the first thing we want to do after a little bit of a sketch. So we have our 90 degree angle here. So that's going to make this side here the hypotenuse. That's side little p. We also have this 35 degree angle. And the side farthest from that 35 degree angle is the opposite. So we want to label that the opposite. That's this side here is the opposite. We would call that side little r. Little r is the opposite. And then that leaves side Q, and this is the adjacent side is side Q, and we know that's 12 meters. It's next to the 35 degree angle. So we want to find the opposite. Okay, so that's essentially the side R or the opposite. That's our unknown. What we do know is is we know the adjacent side. The adjacent side is 12 meters. So we know the adjacent, we know the opposite. What we need to find is some sort of identity that's going to relate opposites and adjacents, because those are the things that we know. So let's go up a little bit. We've got sine, cosine, and tangent. SOH CAH TOA. And I want to find a relationship that's got the O and the A in it. So if I'm not really sure, I might find a little bit of a side space and do SOH CAH TOA. Okay, and if we take a good look at the TOA, it's got the O and the A in it, and that's what we have in our question, the O and the A. We want to know the O, we know the A. Let's start with the formula. So we have tangent of theta is the opposite, the O over the adjacent, the TOA, or probably the A of the TOA. Okay, so tan theta is opposite over adjacent. Let's sub in some values at this point. The opposite is what we're after, so maybe we can just leave that as opposite or OPP. Maybe we could call that side R, whatever you'd like. Throw in a question mark, whatever you like, whatever makes you happy there. The adjacent side, that's side Q. We know that that's 12 or 12 meters. And then we have tan. The tangent is an identity, it's a function, it's a button on your calculator. And that's maybe as much as you need to really know about tan at the moment. Now, theta is 35 degrees, so that angle that we know about or care about is 35 degrees, and we're pretty much set here. Okay, we're going to keep our equal signs in a column and work down the page. We want to isolate the opposite. We want to isolate the piece that we're looking for. So to do that, we're going to really just keep the tan 35 by itself. And tan 35, if you throw that in your calculator, it's just a number. But we don't want opposite divided by 12. We want the opposite by itself, so we have to multiply 12 on both sides. And we end up with 12 times tan of 35 degrees is the opposite. So again, let's see what does that really look like, right? So we have 12 times, and then tan 35. So I want to grab my calculator. I want to press tan 35, see if I get a decimal. If not, I press 35, then I press tan, and my calculator should hopefully tell me 0.700207, and so on and so on and so forth. I'm going to leave that all in my calculator, press times 12 equals, and I'm going to get the length, or the calculator is going to tell me the length of the opposite side is going to tell me it's 8.4. Now, these happen to be meters, so the length of the opposite side is 8.4 meters. The length of the opposite side is 8.4 meters. Yep, that's my youngest. She's playing with the dog, I think. This might be the other sound you probably hear rolling around on the floor up there. So, best advice at this point, I would suggest that you pause it and find adjacent side length. Okay, so find the length of side. Oh, we know the adjacent, we know the opposite. Let's say find hypotenuse. Okay, find the hypotenuse of side length. That would be side P. Okay, and actually, you've got two ways of doing this. So to practice today's stuff, don't use Pythagoras, don't use c squared equals a squared plus b squared, but that'd be a nice way to double check. Instead, use one of the trig identities, see what happens. See if you can find the length of the hypotenuse without using c squared equals a squared plus b squared. Okay, so hope you get a shot. I'm going to run through that as best as I can right now. We're looking for the length of the hypotenuse, and I have really a whole bunch of options because I know two side lengths here, but I'm going to make use of the adjacent because it's 12 meters. It hasn't been rounded. It's going to be nice and even, and I want to find the opposite. So what I really want to look at, I think, is, the trig identities. I'm really looking at SOH over here. Sine theta is the opposite over the adjacent. So I'm going to start with that. Sine theta is the opposite over the hypotenuse. Sorry, not adjacent. Sine theta, opposite over hypotenuse. Following that, I know most of these things, but I'm looking for that hypotenuse. Oh, maybe I don't want to use sine. Like I said, I want to use the adjacent, so I'm going to use cosine. Again, sorry about the noise. I think that's my dog dropping a bone on the floor. So cosine of theta is the adjacent over hypotenuse. Let's plug in some stuff, see what we get. We're looking for the hypotenuse again, so that's going to stay as h. The adjacent, is a piece we know. We know it's 12 meters. Cos is just the button on the calculator at this point, so let's just keep the cos. And then the angle's 35 degrees. So previously, we had to move some stuff around to get to the h. So we're going to do the same thing. But what we want to be careful of is to do the same thing instead of just doing what is convenient. And by that, all I mean is the h is on the bottom, so we bring it over and we multiply. Now I know what you're saying, but that doesn't get the h by itself. You're right. So we're going to do some more stuff. Okay, so now we have to divide by cosine of 35. And if we do it on the one side, we got to do it on the other. And again, if you don't like looking at it as cos 35, just plug it into your calculator, cos 35, and you'll see that it's just a number. I know it looks pretty intimidating, but it's just the number 0.8. That's all that we're really talking about is the number 0.8. But in terms of the equation now, it looks like the h is left behind. We have equals 12 over cosine of 35 degrees. And again, this cosine over 35 is the cosine over 35. They're going to divide and equal 1. So we're left with the hypotenuse is 12 over cos 35. So I take my calculator, 12 divided by cosine 35 equals, and it tells me the hypotenuse is 14.6. Now that's a side length. We're looking at meters here. If I had a little bit more space, I would put in a nice therefore statement. The length of the hypotenuse is 14.6 meters. Okay, so there's a another example there. Take a good look at it if you'd like to. Double check how your calculator works and the rearrangement of some of the steps. The example you see here is another case where like the unknown is on the bottom, so we have to bring it over and we multiply just like we did last time, and then we end up dividing that sign off the other side. Okay, so that might happen, something you want to prepare for. Following that is just some practice. There's two key terms we should take a look at in the next two problems, but what I'd recommend you do at this point is pause the video, try the problem, this problem here, what is the length of side B? Once you have a solution, play it, and we'll see if we get to the same spot. Okay, if not, jot your questions down. Let's see what we want to do. Okay, so the first thing I'm going to do is I'm going to hope that you've paused it and tried it yourself, and you're going to go through this with me and check your work. But I'm going to start out by drawing a triangle ABC. Side A is 6 meters long, angle CAB is 90 degrees, and angle ABC is 30 degrees. So we know we have a nice right triangle, or at the very least a right triangle. And who has ever known a right triangle to be anything other than nice? Of course, they are right, not wrong. So we have A, B, and C. A couple points on the right triangle, a couple angles or vertices. We have angle ABC is 30 degrees. So angle ABC, so we're looking at that B is 30 degrees. Sorry about the dog noise, that's got to be really annoying. And then side A is 6 meters. Well, this is side A is 6 meters. Okay, and it turns out that that is also going to be the hypotenuse. We have this 30-degree angle here, so that makes this side along the bottom, side little c, the adjacent, and this side over here on the left side, the opposite side, that is side B. And again, we want to know the length of side B. Well, there we are. So we know something about the hypotenuse, we know something about the opposite. I want to think about what identity do I use. Do I use SO, CAH, or TOA? Well, we know the hypotenuse. So it's this one or this one, sine or cosine, and we want the opposite. So it must be sine. So let's get rid of these ones, and we are going to start with sine of theta is the opposite over the hypotenuse. At that point, we can sub in some of the things that we know. We know the angle, so we know theta is 30 degrees, and the opposite's what we're looking for. So you can call it O, you could call it side B, no problem. Call it your question mark, it's all good. The hypotenuse is 6, or 6 meters. Now at this point, we want to isolate that O, we want to isolate that opposite. So I'm going to really just need to keep the sine of 30 degrees there and move the 6 away. And that's to say we need to multiply 6 on both sides to help cancel out that 6. Just to help us maybe make some sense of this, I'm just going to put in sine 30 and in my calculator, show it to you. It is really just 0.5. It equals side O for the opposite. Okay, just so we remember this is the opposite side. So we have really 6 times 0.5. I can plug that in my calculator, or really I could do 6 times sine of 30, and it's going to tell me it comes back as 3. and those would be meters, and that's the length of the opposite side. Therefore, side B, maybe what I can say with the length of side B is 3 meters. Okay. And of course, you have something different. That's great. Come and show me. Let's talk about it. We can figure out what happened. Maybe I made a mistake. Maybe there's something to learn here. Let's give it a shot. Okay. Up next, some key terms. So this is the first time we're going to talk about some of these key terms. You're going to see them through quite a bit of problem solving. They are going to come up when you take a look at some problems. Those are the terms angle of depression. Angle of depression. You're looking down. Just like that term might imply in other kinds of contexts. Depression, you're looking down. And that's to say, from the horizontal, you look out horizontally, and then you have to look down. It's generally a situation where you're up high, like on the top of the Eiffel Tower, and you're looking down to a person below. Or a boat, and you're on a cliff, and you're looking down at a boat from below the cliff top. Something like that. The other possibility is the angle of elevation. And this is a line you're looking out horizontally, and then you have to look up. Because if there's a bird, it's a plane. No, it's Superman up in the sky. And you're wondering, what's that angle when you look up? So angle of elevation, looking up. Angle of depression, looking down. So here we have a problem. It mentions real-life applications and problem solving. It mentions that a surveillance video is used to calculate distances. Very common. A flagpole is known to be 3.25 meters tall. The shadow from the flagpole is cast on the ground. The angle of elevation from the end of the shadow to the top of the flagpole is 65 degrees. How long is the shadow? So here's our sketch. It says that the flagpole is 3.25 meters tall. So that makes this side of the triangle, this vertical side here, our flagpole. And in true Mario Brothers fashion, we will put up a little Mario flag. It also mentions that there's a shadow. So this is our shadow along the ground here, up along the bottom. And the angle of elevation checks out from, horizontally looking up is the 65-degree angle. We want to know how long is the shadow. So that's to say we want to know how long is this side. We can call that side little a, because up top we have angle A. So what we need to do is figure out the names of sides in the triangle. From there we can figure out an identity, sine, cos, tan, and we're off and running. So let's label a couple sides. First up, there's our right angle. So this is the hypotenuse, the diagonal line. The flagpole then, that must be our opposite side because we know that angle is 65. So this over here is the opposite side, 3.25 meters or 325 centimeters. So that leaves side A, and that must be the adjacent. It's next to the 65-degree angle. It's the last side that we don't know. So then we check out our identities. Is it SO, CAH, or TOA? Well, we want adjacent. We know opposite. So we want adjacent. We know opposite. That's got to be the TOA. That's got to be tan. So let's start out with that. Tan theta is the opposite over the adjacent. We can sub in the angle. That's 65 degrees. The opposite. Let's go with 3.25 meters. Why not? You could use the 325 centimeters. All good. And then we have left over the adjacent, just side A. So, again, we need to get that A all by itself. Because we're dividing by A on the right side, we're going to have to multiply by A on the left side. So let's keep a few things. Let's keep tan of 65. And actually what makes this maybe a little bit easier to look at is that's not tan of 65 if you don't want it to be. You could just call it 2.14450. But if you're going to do that, you need to carry at least 4 decimals, if not more. So I'm going to leave that as tan 65 degrees. Leave the 3.25 meters behind. And what's going to happen is we need to multiply A on both sides. So we have A times tan of 65 equals 3.25. Sorry. So now we don't want A times tan of 65 degrees. So we have to divide that off of both sides. And again, tan of 65 degrees is the number 2. Okay, it's not quite 2. There's more decimals to that, and we need to keep those decimals to keep the precision of the answer. However, if we look at that, we have A, the tan 65 over tan 65, that's going to cancel. It's the same thing over itself. It really looks like 2.14 divided by 2.14. So they're going to divide and give you 1. So the A is going to stay. And on the right, we have 3.25 divided by tan of 65. Okay, that's like 3.25 divided by 2.144506921. Okay, so if you turn the tan of 65 into some decimals, you end up having to write a lot of decimals. It gets a little annoying, and you lose some precision that way. But if you want to do it that way, no problem. So let's see what that turns into. I'm going to grab my calculator, and I'm going to press 3.25 divided by tan 65 equals. My calculator works that way. Your calculator might work a different way, but what I got was 1.515, and those are going to be a length in meters, or that's a side length in meters. So again, I want to be careful how my calculator works, and for you to understand that your calculator might work differently, and if it does and you get a different number, then you might be doing the right thing. It might just be a setting in your calculator, so please let me know. So therefore, the shadow of the flagpole is 1.5 meters long. Okay. Of course it is. Of course, if you have questions, of course, please let me know. Probably tired of me saying, of course. So up next, one more for you to give it a try. Please pause it, give it a shot, give it a play. After that, if we're on the right track, it'll look good. If not, you got some questions, we got something we can talk about, something we can work on together. I look forward to it. So here we go. Hope you paused it, hope you tried it. We're going to take a look at this. Park ranger in a tall tower surveys a meadow. Sounds like a pretty good job. Smoke is seen rising roughly 250 meters away. The park ranger estimates the angle of depression to the source of the smoke to be 25 degrees. So that must mean this is our smoke here. And maybe we've got our fire down here. Oh no, it's a fire in the forest. Let's do something about that. Okay, so that's the story. How far away is the fire? Here's the fire. Here's the forest ranger. If I could draw a hat, I would draw a forest ranger hat. That is clearly a forest ranger hat. So here we go. We gotta maybe label some sides. First things up, nice little square. So that's gotta make this our unknown, the hypotenuse. Okay, so we need to find a hypotenuse. We have 25 degrees. That's gonna make this side over here the opposite because we know that angle there. And then that makes this side, the 250 meters, the adjacent side. So we know the adjacent, we need the hypotenuse, we need to find an identity that has those things. So, well, there it goes. It is SOH, CAH, or TOA. Okay, so we want a H, we want a hypotenuse piece, and we know the adjacent. So it looks like we're going with cosine. Okay. Cosine theta, let's do that again. Cosine theta is the adjacent over the hypotenuse. The adjacent is 250 meters. The angle is 25 degrees, and we want to find the hypotenuse. So again, that hypotenuse on the bottom, we need to bring it over to the other side and multiply. So we'll keep our cos 25, we'll keep the 250, and then that h is on the bottom, so we bring it over and we multiply. Now we're left with h times cosine of 25 equals 250. We don't want that. We want to divide out that cos 25 degrees. If we do it on the one side, we've got to do it on the other side. So what we're left with then is the hypotenuse is equal to 250 over cosine of 25 degrees. The cosine of 25 degrees, what's that? Looks scary. There's a lot to it. There's letters, many of them. It's actually the number 0.90. 0.906, that's all it is. No, it looks scary, but it's really just a number. So I'm going to solve that whole piece. I'm going to take 250 divided by cosine 25 degrees equals 275.84, and so on and so forth. So therefore, the fire is 275, let's say 0.8 meters away. Okay. If you have something different, come show me. Let's see what happened. Maybe my calculator is messed up and I got the wrong settings and I don't know because I haven't checked. I've only got the one calculator. Maybe we need to figure out how your calculator works in that settings. Or maybe there's just good questions and maybe we just looked at it a little bit differently. But I hope you have a great day. Please try the practice. If you have any questions, of course, please see me, please email me, please let me know. I hope you have a great day, everybody. Take care.